All right, thanks. I think I'll just hold everything. Let me know if there's a problem. I won't be too long. I really just made a short lightning talk talking a bit about what I'm working on right now with a student. So yeah, I'm at Universite Laval. It's in Quebec City, so a fellow Canadian. I think I'm running out of hands, so I'm just gonna try using this here. So this is work I'm working on with a PhD student, Leila, whose face is there. So what we're thinking about is inference from differentially private synthetic data sets. And the idea is that differentially private mechanisms involve some sort of randomization. We've heard all sorts of discussions about this today. And so there's some sort of additional variability that comes into those data sets. And so we can't just use the usual inference. And we've talked about this quite a few times already this morning. And I've been thinking about this for a long time. So that was my first attempt at thinking about this a while ago, where I was looking at differentially private synthetic data sets that were generated from a known transparent mechanism. And I wanted to take into account the way the mechanism created the synthetic data to get better inference. And what I tried to do is using combining rules. So we've heard sort of more complicated ways today of trying to take into account the mechanism, but in the statistics literature, so we heard about imputation earlier. So in statistics literature with missing data, there's been a lot of work on imputation. And so sort of just making up the data that's missing. And some of that work definitely is about doing inference when you have imputation. And a sort of very simple way of doing this, which is very easy for the users, is using combining rules. Well, we just call them combining rules, but basically what you do, so I have a little bit of formulas here, but the talk is really not technical. I just want to sort of tell you what I'm working on and see if anyone has advice or input. And so basically what you're doing is you have to generate multiple versions of the data set, and then the user just analyzes each of them as if it was the original data. So there's nothing different you do for every one of them. And then you get these estimates. They're the Q there. So you get the estimates you want, and you get a variance estimate for that estimate. And then there's just this super nice combining rules where you can show that if you combine this inference from these multiple synthetic data sets, well, originally from imputed data sets for missingness, then you'll get valid inference. Okay, so the trick here is that for a user like me, who just learned about imputation, it was very easy to just throw these combining rules at it and get valid inference. And so I thought, now I'm doing differentially private synthetic data. Can I use the same things? And the answer is no, you can't just use those combining rules. In that paper, it didn't work. And I was using a very simple model to generate the synthetic data. But with this very simple model, it was easy to model the whole thing, sort of a tiny, tiny part of the holy grail we were talking about this morning of taking into account the mechanism. Well, for the very simple model, it was easy to do it. But for more complicated models, it wasn't as clear. But the model I was using there is a pretty bad way of making synthetic data with differential privacy. And so what I'm thinking about, right, okay, so it doesn't create very good data sets, and if you use more complicated methods, then it's really hard to take into account. And so the goal was to sort of see, there's been a ton of new ways of creating synthetic data sets published, and maybe some of those are good enough that they're kind of like sampling from the actual posterior predictive distribution. Like they're good enough that maybe we can actually use those with the combining rules. So what we're working on is really more empirical validation of what if I'm using the same combining rules I tested before, but with better models. And actually there is related work that was published not that long ago. Well, it's an archive still, I think. And here what they're doing is looking at one specific way, so they call it MODIPs, one specific way of creating differentially private synthetic data sets multiple synthetic data sets in a specific way. So it's called model-based differentially private data synthesis. And they actually show that you can use some combining rules to get inference if you use this method. And so we were wondering, can I use this for more complicated methods? Because people are publishing now ways of making synthetic data set using like deep learning. And it's going to be pretty hard to combine all of this in this very large inference model. And so we just worked with a few different DP synthesizer. So we've been playing with a data synthesizer, who some people might know as PrivBase. And so basically it works with Bayesian networks. So you model the data using Bayesian networks, but you add some randomness in the modeling so that you get differential privacy. And we've also been playing with another method that uses Vine copulas. So I don't know if copulas are familiar to people outside of statistics, but it's a way, so what copulas allows you to do is that you'll model separately each of the distributions for the variables. Like you have multiple variables in your data set, you model them separately, and then you have the copula that handles the covariance between those distributions. I'm not going to go much further. This is a lightning talk, but they have some very nice code that we can use where they, so Vine copulas, it's basically sort of like a vine, like I don't know if that's a, yeah, right, the vine, like that's the grapes. So like you're basically building the copula. Anyway, it's a nice way of doing it, and you can get differentially private synthetic data set, and it works really well. And we also want, and that's partially why I'm talking here, I don't have like completed results. I'm just, talking so we can talk in the next 5 days. But we're looking for something using GANs or deep learning that generates synthetic data set that we can use. And the thing is, like, we're not specialists in GANs or deep learning, so we'd like to get some code to generate synthetic data. So if anyone has any advice on where to get that, let us know. But we've been playing with those two right now, and this is some small results that we get. The figure is not completely up to date. My student was still working on it, but basically, I'll show you the one interesting thing we're finding is there's this combining rule TP, which is the same that was used in that paper I just mentioned, where they're showing that they can actually use combining rules to get inference. Well, what we see here is that if we use, so the first part here is with the data synthesizer. So we're looking here at the variance estimate of a slope estimate for a regression. We're using like a data set with only three variables. But so we're looking at the estimate of a slope for one of the variable. And if we use this TP, we actually get pretty much unbiased estimate of that variance of our estimator. And it works well with the data synthesizer mechanism, and it works well also with, so here with smaller epsilon, there's such a difference in the estimate is much more variable with data synthesizer than with the Vine copula method. So it's actually a much better method, the Vine copula, but somehow she sort of didn't get the values to appear in the graph. But we get the exact same thing, so we can look with this larger epsilon. We also get pretty much unbiased estimate of the variance estimator in that case. And so, so the idea here is that, I mean, this is probably not the best way of doing it, but for people who don't have access to complicated methods and don't have very good computational power, anything like that, using these combining rules would be very nice if it actually worked. And it seems like maybe in some cases it does work. So we're still looking, into how well it does. And the other bars that you see, yes, sorry, there's a bunch of other bars. She was comparing to a bunch of other combining rules that exist for different imputation for non-response, but the one that we thought might work is this one, and this is the one that works. So yeah, that's my lightning talk. I really just want to share what kind of questions I'm working on in case anyone want to talk about this in the next few times. That's my face. Well, now I took the mask off, so you can try to see me. But, all right.